Welcome to the Data World Friday. My name is Michael Olschimke. I'm the CEO of Scalefree. We run this session here every Friday to allow you, the audience, to ask questions about data vault, data-driven applications, data mining, cloud computing, MPP clusters, anything you want, essentially, anything data-driven, especially. And you can use it. Essentially, you can use a chat here in the client to raise a question. You can use the Q&A function in the client. You can raise a hand if you want, not physically but virtually, and then I'll give you voice. Or you can use a form which I'll show you after today's session, where you can also type in the question, maybe upload a picture of your team, of your whiteboard, and then allows me some time to prepare a slide at least. If we receive multiple questions, and we have a couple of questions on the backlog at the moment, so stay tuned and stay patient, because all of the current questions we're going to answer eventually. But we're cherry picking essentially, and it's time box. So we're looking at questions roughly 10 minutes. And then if there's no questions at all, I will talk about the cluster here. But thank God you're asking questions, because I didn't have much time to work on the cluster, to be honest. So that's in all honesty. All right, let's take a look at today's question. This one here is really about, let me just clean this up here a bit. This one is really about hashing. And let me read this roughly at least to you. I have a question regarding an integral aspect of Data Vault 2.0, the hashing of business keys and hash diffs. Since Data Vault is technology agnostic, it is adaptable to various on-premises or cloud databases and data platforms. What are the general recommendations when the performance cost associated with hashing becomes too high? This issue might arise when calculating hash diffs for wider tables, or when complex functions are required to ensure unique strings for hashing. Additionally, scenarios might occur where clients begin comparing the cost of data loading between new and old solutions, or when a client's local, client's local on-premises hardware is relatively weak. From my perspective, the long-term benefits of hashing are clear, particularly when the data solution is distributed across several regions and built on diverse technologies. Calculation of hash diffs utilize compute power during loading with goal to make execution of queries above loaded data more efficient and therefore cheaper. There's clear trade-off or move of performance needed for querying to performance needed for loading. However, and that's a real question now. However, for smaller local solutions, would we break the standard if we choose not to use hashes? So let's discuss briefly all three options that you have, and then what arguments I would essentially take serious here, and maybe some arguments I might want to debate essentially. So you have three options on the table. You could use hash keys, which is the standard solution these days. So if you don't know what to do, use hashes. That's the basic idea. The advantage of hash keys over the other two options, sequences, as in Data Vault 1.0, and the business key itself. I mean, why would you hash, right? Why don't you just keep the business key as your identifier, your primary keys, and the foreign key references? So those three options are on the table: hash keys, sequences, and business keys. That's always a bad one, the sequences. It's on the table, but the problem is all our customers who use sequences, they want to get rid of them. Those are the migration projects. The problem with sequences is that you have essentially, during loading, you have to perform lookups. And those lookups are presenting I/O performance that you have to consume. I mean, you're going against disk, right? So you're consuming I/O performance. And that typically slows down the loading process even further. So when you compare loads with sequences and hashes and business keys are faster than sequence-based loads. So that's number one. And sequences have some other disadvantages. There's a dependency chain. So the orchestration for loading the raw data vault becomes a bit more complicated. You have to load hubs first, then links and satellites, roughly. And this might work in batches, but in real time, when it results in waiting states. That's the other issue, right? So you have to wait all the time to absorb messages into your system. But I think one of the biggest issues is if you have a distributed system, and that's what you're saying here as well. If you have a distributed system, then having sequences means when you have, let's say, a part of the solution in the cloud and a part of the solution in the on-premise installation, let's say some dimensions and facts. Let's say the facts are in the cloud, the dimensions are on-premise. The sequences don't match. So you have to figure out when you join from the cloud into the on-premise installation. I mean, good luck with the firewall, right? But let's say you join from cloud to on-premise. The sequence will not match. So you have to use a business key from the cloud to figure out what is the sequence of this business key in a dimension on-premise. So you can then continue joining, right? Because you might need more than that. In each individual system, in the individual system, you have to essentially join based on sequences, but across the environment, you have to join based on business keys. That's the only thing you have. So it makes the query patterns much more complicated, in my opinion. I mean, we can still automate this to some extent, yeah, but it's still more complicated and less efficient, right? So sequences are typically not a good option anymore, even though theoretically you could use them. But most customers, I would say all customers, I'm not 100% sure, but most customers don't use them anymore, except the migration customers, essentially. So that leads you to two realistic options: hash keys or business keys. And it's not really about distribution or not. It's really about the technology you're using. There are some platforms where they hash the primary keys, the foreign keys, and the primary indexes. That essentially stems, I believe, originally from Teradata. They do this in order to improve the join performance across nodes. And this pattern is used by or utilized by many MPP databases, like Exadata. I know for sure on Exadata. I believe on Greenplum as well, and on Exasol as well. For Snowflake, they use a different pattern, but it's still the case that they use something similar, essentially. And what we see then is when they hash the primary keys, foreign keys, and primary indexes, or do something similar, then what happens is that the joins based on business keys are also performant. In the end, the hash key that we use is a trade-off. The idea is this. The first thing is, what people do is often they look at the business key. Let's say you have social security numbers, 12 characters or whatever, 12 characters, fixed length. And you say, well, why would I hash this? It's too long, right? And you compare this on a hub, and it makes sense. On a hub, the hash key would be much longer than the social security number. But it's a very uncommon pattern, query pattern especially, to get just to query a bunch of business keys. That's it, right? Without descriptions or something. That's a weird pattern, weird query pattern. Typically, you want to have some dimensions, and that means you want to have the business key and its descriptions, for example. Or you want to have facts, and facts stem often from non-histographic links. So the problem now is on your non-histographic links, it's not a business key anymore. It's a combination of business keys. This social security number for this vehicle identification number, paid tax in this region, and so on. So a couple of business keys involved, and then where the primary key now, all in a sudden, is a combination of all the business keys. And all in a sudden, it's more than 32 characters or 40 characters, or maybe 16 bytes. It's much bigger. And that's not your biggest problem. The biggest problem is if you have a satellite attached to it, to this non-histographic link, especially if it allows deltas. Could be the case. You might have transactions where you have updates, changes to the source data, right? So not nice, but so be it. And in this case, you're replicating the primary key from the non-histographic link into every single delta. And that's the issue, essentially. So the hash key gives you one advantage on all the systems. It will give you a fixed length hash value, or fixed length identifier, essentially, for your data. And no matter what you're querying, if you query the hub, the link, the satellites, doesn't matter. Everything is 16 bytes or 32 characters or 40 characters long, always. And so it might be slower in join performance, query performance, when you compare to sequences, because, I mean, seriously, a 16-byte hash value is the smallest MD5 you can store, essentially. It's twice the size of the big ends, so it must be less performant, period. It can't perform better. On the other hand, compared to the business keys, the hash key gives you a consistent query performance on typical queries. So that's the idea. So the hash key works well on most platforms, and you could deviate from the hash key if your platform supports it. If you're on Synapse as well, Synapse or Snowflake or Teradata, what else did I say? Exadata and so on. If you're one of these platforms, typically the more modern MPP platforms, you could go away or get away with using the business key. But then the problem is if you have a mixed environment, let's say part of your solution is on Synapse or Snowflake, and part of the solution is on a platform that doesn't support this, I like to call this Teradata pattern. The problem is then you have complex joins again. And think about this. One of these platforms is your data lake on S3 or Azure Data Lake and so on. That's where you also don't have this pattern. And which means that if you don't use hash keys, you again have to, if you want to join between data lake and the raw data vault, you again have complex joins, right? And different joins, depending on what you want to join, which environment, maybe an on-premise, I don't know, Oracle database where parts of your database is also located, then you get into issues again. So by default, we go for hash keys, but here's the thing. if we meet again in, let's say, 30 years and we're sitting on the beach, all retired, I will tell you, we'll share these stories, right? And I will say, well, you know what, guys, when we met in this online stream here, when you watch this on YouTube or whatever, remember, and there's proof now, there's a recording essentially, it will not go away most probably in the next 30 years. I recommended to use hash keys. But nowadays, I mean, in 30 years from now, the young guns, they use all essentially business keys. Why? Because in 30 years from now, not even for academic purposes, you're going to use a non-MVP database. Even for academic purposes, everybody's using MVP databases in 30 years from now. But the problem is, so in the future, I truly believe that we're going to use business keys. Problem is, with the tool stack right now, especially because I don't know you guys in front of me, right? With your tool stack, I most probably would recommend using hash keys instead of business keys today. But anywhere, anytime between today and in 30 years from now, I'm going to switch my, I'm going to change my opinion. That's for sure. But I don't know when. And in some cases, we already recommend using business keys over hash keys, but it's very seldom because customers, even if you say today, we don't see this mixed environment, you can't rule it out. And it's actually in many cases more, the chance is higher that you have a mixed environment soon than less. So that leads to the fact that we typically recommend using hash keys by default. Now, so with that in mind, 3 options, that's what you have. Hash keys is a default option, especially in mixed environments where you don't have all the parts of your solution on a MVP database that supports a Teradata pattern. We would recommend hash keys. Sequences, we don't recommend. It's on your table. You could use them, but typically you don't want them. You want to use them. And the only other option is to use business keys if all your platforms support the pattern with business keys, essentially. Because otherwise you get a in-performance solution, essentially. Very complex joints, essentially. So that should drive your decision. That thinking here. So which means that we'll look at the so for distribution purposes, absolutely. I mean, the business key you can also easily distribute. So there's no reason to hash business keys if you want to distribute, right? Both would work essentially. The sequences are the problem. Yeah, that's all good. And then for the loading performance, I would always trade loading performance for higher query performance. That's essentially my take on this. So yeah, that's what you see here, the clear trade-off. Yeah, so I fully agree on the second bullet point here. And you don't break this down. You have 3 options essentially, right? Sequences, hash keys, and business keys. Let me just go back. And I had some comments here. One second. Right. So for when you calculate hash diffs, what we see is the wider the table is, the larger your satellite is, the more columns you have in your satellite, the more attributes, and the more data records you have. The higher should be the impact of your the positive impact of your hash diffs. Having hash diffs should speed up the loading process. I mean, not the loading, not the query process, right? Because we don't use them in queries. Now here's the thing: when you look at when you want to measure the performance of your hash diffs, don't just do a initial load. That's what people do. They just load a satellite and first time, and then wonder why it's the same speed with hash diffs compared to not having hash diff. Well, the hash diff is used in delta checks, right? In an initial load, there is no delta check, or there's no delta check happening because there's nothing in the target. That's number one. And then what we always say in the training is, to make it a bit easier, we say we calculate the hash diff on both sides, the staging area and the satellite. And when the inputs to the hash diff calculation is the same, the hash diff must be the same. And if not, there must be a change somewhere. But in full honesty, and I always say this a bit later in the training, most of the time at least, the problem is, the advantage now is that we don't calculate the hash diff on both sides in a run. We only calculate the hash diff on the staging area. And when we recognize a new or changed record in the staging area compared to the target satellite, we copy the record, the whole delta from the staging area into the satellite, including the hash keys, the hash diffs, the load date, all the record sources, and so on. So we copy the hash diff from the staging area, which means we're only doing half of the work this time, right? Only one side. That's why we're calculating the hash diffs. The other half, the hash diffs in the satellite, have been computed in one of the previous runs, which means that you want to essentially load, when you want to look at the performance of your loads and compare a satellite with hash diffs with a satellite without hash diffs, you have to do multiple loads with actual deltas. And so have multiple runs essentially, and then compare the overall loading performance. That's what you have to do essentially. So, and then you can easily beat, especially on large satellites, you beat the traditional approaches without having a hash lift value essentially. And also with a, let's say, legacy system that they've built, like a non-data vault solution, I should say traditional solution. They typically have other loading issues, so I wouldn't be scared of losing a benchmark with data vault and hash diffs versus a traditional data warehouse with all the dependencies and so on, without hash diffs. So I wouldn't be scared to this. And especially if you have relatively weak hardware, I mean, the hash diff is more performant overall, right? So again, compared over multiple runs, and then you see the value. This is not an argument here, especially on relatively weak hardware, you would go for it. On-prem, there's a couple of issues then. Well, a couple of issues. I mean, the hash calculation is typically highly optimized, so I wouldn't see a big deal with calculating hash values as well. Depending on the platform you're on, there's like on Linux systems, there's the OpenSSL library, and they have highly optimized implementation of the hash algorithms, and that's what many applications and database systems use, or at least applications, I know for sure. They use these OpenSSL libraries, and that's one thing. If you have to calculate a lot of hash values, there's even some hardware pieces, PCI Express cards that you can plug into your computer on-premise, most probably. And then with this card, they come with crypto chips essentially. And these crypto chips are essentially plugging in as a extension into this OpenSSL library, and then give you hardware to calculate hash values. So could be an option as well, especially on-premise, right? So I'm not sure how expensive they are, to be honest. Never paid for them, but could be an option to calculate MD5 and SHA-1 values with hardware instead of with code. On the other hand, to be honest, your CPU, your Intel and AMD CPUs, they have the hash computations in the instruction set as well. So yeah, I just believe, at least the marketing here, that these hardware crypto cards, they should be faster. All right. Good. And they fully integrate in these OpenSSL libraries, right? All right, cool. Yeah, so a couple of comments. I don't want to say anything here, right? I'm not committing here myself on one of these three options because I don't know your case, your hardware, your platform you're on, your database platform, and so on. So I wouldn't say no to anything here, not from the stream, but I give you those three options. Sequences, business keys, hash keys, and hash keys is the default option for most cases. All right, cool. That's it for today. No clear answer. So if you have a question like this and you want to have a non-clear answer like today, use this form here at sfr.ee/dbfriday. That's where you can type in your question. That's where you can also upload some diagrams if you want, or just pictures from your whiteboard if you want. It's good enough. Doesn't have to be fully professional here, right? So and I would use your whiteboard. So I would show the picture essentially. And we also have additional webinars, one on DBT and one on Warescape. So check out scalefree.to/webinars. That's where you can sign up for those monthly webinars. And not with me, but with a tool expert from Scalefree. Essentially, they know the tools much better than me, our employees. So yeah, that's the idea. And if you can't wait until next Friday, I mean, it's just a week, right? Join the Data Innovators community. That's essentially a forum-style community where you can also ask questions. And there's a lot of people from Ignition Data and from Scalefree jumping in on your question as you type them in and answering them essentially. So yeah, check it out as well. It's a great platform. We're moving more and more assets, essentially, like knowledge-based articles and white papers also over there. So it's a bit more than, well, actually much more than just a community-style forum board or something. All right, so cool. Thanks for joining. Weekend is the sun is getting up here, so well, it's already up, but it looks like looks like a very promising weekend. So enjoy your weekend, guys, wherever you are, and yeah, see you hopefully next Friday, guys.